Hello, welcome to Royal Achievers Educational Limited, presenting Royal Tutors, the trusted support for brain-friendly, high-impact learning. Today, we'll be looking at the Paper 1 AQA GCSE Physics overview. We're going to be looking at some of the topics we expect to cover under this particular exam board, and then we're going to quickly look at each topic revision before taking some exam questions that have been set over the years. The Paper 1 topics include just 4 topics. We have energy, electricity, particle model of matter, and atomic structure. But for today, we'll start with energy, and thereafter we'll look at some questions in regards to that topic. Energy. Energy is ability to do work. However, in physics, we can refer it to like a system. A system is just like an object or group of objects. When a system changes, the way energy is stored also changes. Let's take, for example, a ball rolling and hitting a wall. The system is the moving ball. When it hits the wall, the kinetic energy is transferred as sound. Another example is a vehicle slowing down. A system is the vehicle moving, and when it slows down, the kinetic is transferred to thermal due to friction between the wheels and the brake. Energy calculation. These are the major formula we use in calculating energy. However, you'll be given equation sheets, so you might not need to worry much about it, but then you need to know it so that you'll be able to identify them from the equation sheet. Kinetic energy is calculated using half mv square, where the m there stands for mass in kilogram, the v is the speed in meter per seconds, and we have the energy measured in joules. Then we have the elastic potential, which we use the formula half ke square. The E there is the elastic potential energy in joules. The K is the spring constant in newtons per meter. And we have the E is the extension in meters. Then we also have gravitational potential, which we measured using mass times gram times height. And also we have the specific heat capacity. Specific heat capacity is the energy that is required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius or 1 Kelvin. And as you can see right there, to measure your specific heat capacity, you have your mass being multiplied by your specific heat capacity and then being multiplied by your change in temperature. Power and efficiency. Power is the rate at which energy is transferred or the rate at which work is done. So if you have to measure power, we have power equals to energy transferred over time, or you can say work done over time. And the unit for power is watts, while your energy transfer is often in joules and your time must be in seconds. Efficiency. To calculate efficiency, you use the formula useful energy output over total energy input, or you can also use useful power output over total power output. So how do we reduce the waste of energy? We can reduce that using lubrication like oil in a motor, which help reduces the friction as well. And also we can use thermal insulation by double glazing, or less useful thermal energy is lost as well. That is the two major way we can reduce energy waste. Energy transfer. Energy can be transferred for use later, it can be stored, or it can be prevented from being wasted. And like I mentioned earlier on, how you can reduce energy waste, you can utilize the double glazing method or oil in motors, or generally speaking, you can just use lubrication method or thermal insulation method. Thermal conductivity. You need to understand that the higher the thermal conductivity of a material, it is allowed to travel through the material more easily. So the higher the rate of energy transfer by conduction across the material, thermal conductivity in a building is another example. The rate of cooling is low if walls are thick and thermal conductivity of the walls are low. So if the walls are thin metal sheets, it would be lost very quickly. Energy resources overview. Okay, we have renewable energy resources and non-renewable energy resources. Renewable can be reused, non-renewable cannot be reused. And some examples of non-renewable include the fossil fuels, the nuclear fuel, but for the renewable resources, we have the likes of biofuel, wind, hydroelectricity, geothermal, tidal, solar, and water waves. Just like you can see from the screen, the key difference is that renewable replenishes while non-renewables is finite. Energy use and reliability. Energy can be utilized in transportation, in electricity generation, and heating. You can also see renewable limitations. Let's say, for example, in solar, when the weather is not quite very okay, it can affect the longevity of that solar system. The same way with wind, even though renewable is quite reliable to some extent, and there are some of the limitations that have been highlighted here. The weather can affect the solar, and the wind not being stable so can affect the use of wind in generating energy. Historical trend, we can see that over the years there have been a shift from fossil fuels to renewables. During the industrial revolution, the fossil fuels became an important source of energy as it was easy to mine and provide a lot of energy. Only recently has renewable energy become more suitable. Technology has had to develop a lot since industrial revolution to be able to harness such energy sources efficiently. It is easier to use energy resources due to increasing pressure to cope with the public's increasing power demands, but harder to solve environmental issues due to political, social, ethical, and economical considerations. Environmental impact. Extraction of energy can affect the environment. For example, the fossil fuels involve destroying the landscapes. The wind turbine can be considered an eyesore in some cases. Even the use of energy sources, we have the fossil fuels, it releases harmful emissions. Solar wind directly creates electricity with no emissions. So the environmental impact can be negative, and in some cases, it can be safer. In conclusion, energy management is key to efficiency and sustainability. In our next session, we are going to be looking at the next topic in paper 1 under AQA exam board called electricity. But for now, we are going to move on to look at some past questions review in line with the topic we just reviewed.
So we're going to continue from where we start. After the revision on the topic energy, it's important for us to also try and answer a few numbers of questions from some past questions. So this particular paper is a foundation paper that has to do with energy. You can see the first question there. It says that the figure below shows part of the national grid linking the power stations to consumers. Name the parts of the figure above labeled A and B. The first thing you need to understand is that if you take a look at those, if you look at that picture carefully well, you realize that this part A, we can say the part A is the cables. We can call it the cables for the part A. If you look at it, you can call it the cables. Some can actually refer to it as the power line. It's still the same thing. So A can be called cables. Okay, and for the B, you can see the small one we have here is called the step-up transformer. So this one is going to be the step-down transformer, so that the charge that's coming directly from the power station will not be too much for your appliances at home. All right, and that is all for the first question, and then you have your 2 marks. So the next question says, electricity is transmitted through A at a very high potential difference. What is the advantage of transmitting electricity at a very high potential difference? Okay, the one major advantage whenever electricity is being transmitted at high potential difference is that less thermal energy is transferred to the surrounding because it's moving at a very high rate. So as a result of that, thermal energy in the surrounding will be lesser, even if energy has been moving at that moment and you're under even the transmission wire. You might not even feel more of the heat because it's moving at a very high rate. Then we have the next question. It says, the power station generates electricity at a potential difference of 25,000 voltage, and the energy transferred by the power station in 1 second is 500 million joules. Calculate the charge flow from the power station in 1 second. They've already given you the equation. You just need to substitute those values right inside the equation. You already know that your energy is 500 million joules. Why? Because the unit of energy is joules. So you write your 500 million joules over, and your potential difference is already given to you in the question to be 25,000 voltage. And how do I know? Because the unit for potential difference is volts. So you have over 25,000. So if you divide this, you're going to get 20,000 coulombs as your answer. It's as simple as that, and you've just gotten your complete mark. That is what's expected of you. All right, let's move on quickly. Let's move on. Look at this next question. Very interesting question. They say the electricity that is supplied to a house has a potential difference of 230 voltage. The table below shows the current in some appliances in the house. You can have the appliance, we have the current in amps. Calculate the total power of all the appliances in the table above using the equation power equals to potential difference times current. This is quite very simple as well, because the first thing you want to do is to calculate the total current. And what do I mean? You have to add everything up. And if you add everything up, that's probably going to give you 7.20 amps. And you can agree with me from the question already, you have already been given your potential difference to be 230 voltage, as you can see right here in the question. So what do? You just go ahead and use the formula that's been given to you, or let me say the equation that's been given to you, that says power equals to potential difference times current. And that means you're just going to multiply 230 by 7.20. If you do 230 times 7.20, that is going to give you 1,656 watts, because the unit of power is watts. You can see right there. Now let's move on. There's each appliance in the table above is switched on for 2 hours. Wow. Which appliance will transfer the most energy? This is quite very simple. Okay, let's go and check the table again. Which appliance will transfer the most energy? Look at it. If you look at it very well, you can see the current in amps for each appliance for dishwater, DVD player, lamp, and TV. So if it's been switched on for 2 hours, so the one that is going to transmit more energy, the one that's going to transfer more energy is going to be dish. It's going to be dishwater, because the current that is being generated in amperes for dishwater is higher compared to other appliances. So if you on it for 2 hours, the highest energy that's going to be transmitted is going to be in the dishwater. So they ask us the following question there. They say, the next question there says, okay, let me first put the answer. This is going to be dishwater. Okay, so the next question there, it says, which appliance? Okay, they say we should give reason for our answer. Why is it dishwater and not other ones that have been highlighted there? It's because dishwater has the highest current. I've already mentioned the other time, because it has the highest current. That is the reason for it transmitting the most energy in comparison to others. All right, quickly, let's take a look at the next one. They say the average energy transfer from the national grid every second for each person in the UK is 600 joules. Beautiful. There are 32 million seconds in 1 year. Calculate the average energy transferred each year from the national grid for each person. Underline the word each person. So you're looking for each person. That is quite very simple. Okay, since they already mentioned from the beginning that the average energy transfer from the national grid every second for one person in the UK is 600 joules. Okay, and we have the total of 32 million seconds in 1 year. Okay, so that means for us to calculate the average energy for each person is very simple. So that's just going to be energy equals to the 600 joules times 32 million. Good. And if you multiply together, that is going to give you energy. It's going to be 19,200,000,000 joules. And you can actually simplify further so that it can be 1.92 times 10 raised to the power of 10 joules. So as simple as that. And then you have your answer. All right, quickly, let's take one more question. Let's take one more question. And we're good. Let's take one more question. Okay, they say the figure below shows a house with a solar power system. The solar cells generate electricity. When the electricity generated by the solar cell is not needed, the energy is stored in a large battery. If you have seen a solar system before, that is how it works. Energy stored in a large battery, and when there is no sun, the energy that's been stored will now be utilized to power the system. So the solar cells on the roof of the house always face in the same direction. Explain one disadvantage that is caused by solar cells only facing in one direction. One disadvantage is just because solar cells are not always pointed at the sun. Are we together now? Solar cells are not always pointed at the sun. Okay. If it's just facing one direction, we'll realize that the solar cell will not receive more solar energy. The disadvantage caused by solar cells facing one direction, it will not receive more solar energy. But if it's facing different direction, it's taking solar energy from this side, it's taking solar energy from that side. So if they ask you to explain one disadvantage caused by solar cells only facing one direction, you can easily put that solar cells won't receive as much solar energy. It won't receive as much solar energy. It's as simple as that. All right, let's move on quickly. They say the mean current from the solar cells to the battery is 3.5 amperes. Calculate the charge flow from the cell to the current to the battery in 3600 seconds. Simple. The formula has already been given. Just put the value. Your charge flow is also Q equals to the current, which is 3.5, multiplied by the time, which is 3600. Okay, so if you multiply this together, that will give you 12,600 coulombs. As simple as that. All right, quickly, let's move on. Let's move on. I believe we are learning. If you are learning, do well to subscribe to this channel for more. Let's say write down the equation which links efficiency, total power input, and useful power output. If you remember, during our revision on energy, I highlighted these particular formulas. Okay, even from your equation sheet, you can actually pick it from there. You know that your efficiency equals to the useful power output, okay, over the total power input, And the beautiful thing in AQA is that whenever you have been asked this kind of question, trust me, the next question you're going to be seeing will have to do with you utilizing that equation in solving the next question. Look at the next question. It's at one time in the day, the total power input to the solar cells was 75,000 watts. The efficiency of the solar cell was 0.16. Calculate the useful power output of the solar cell. The first thing you want to say there is that you have been given the efficiency to be 0.16 and you have been given the total power input to be 7500 watts. So you just need to put the value. Okay, your efficiency 0.16. Okay, you are looking for your useful power output, okay, and you have been given your total power input to be 75,000 watts. So all you need to do is to multiply your 7,500 watts by 0.16 to get your useful power output. And 7,500 watts by 0.16 will give you 1,200 watts, which is your useful power output. All right, let's see if you can still take more questions on this one. Okay, they said the wasted energy that is not useful, the wasted energy that's not usefully transferred by the solar cell is dissipated. What happens to energy that has been dissipated? When we say energy is dissipated, what does it mean? It means the energy becomes less useful. That is what that statement means. It means the energy becomes less useful. The energy becomes less useful. Okay, let's take the last one. So why is it unlikely that all the UK's electricity needs could be met by solar power system? Why? Why is because a very large area would need to be covered with solar cells. You want to actually ensure that it's electricity in the whole UK. That means we need a very large expanse of space that's to be covered with solar cells. That's when we can generate electricity for the whole UK. So that is the reason, the unlikely for UK electricity needs to be met by solar power system. So I'm going to stop on this question for now. I believe you've learned one thing or the other regarding the topic energy and also how to answer a relative question on energy. In our next class, we are going to be looking at electricity. Do well to follow this platform for more and do well to subscribe to get notified whenever we upload a new video. Thank you so much for following Regular Shivers Educational Limited today. See you some other time. Bye-bye.